Hi guys, this is Mrs. Lyons, and this video is going to walk us through how to do molarity calculations. All right, so first thing we need to know is what the formula for molarity is. And the formula is going to be capital M, which stands for molarity. So capital M is molarity, is equal to the number of moles over the number, and this is going to be, let's be a little bit more specific, moles of solute over liters of solution. Okay, so molarity, capital M, is either going to have the units of moles over liters, or we can just use a capital M to symbolize molarity. Okay, so when we do these calculations, we're always going to be looking for three things: the number of moles, the molarity, and the volume. Okay, so the first step that we're going to want to do in most cases is we're going to want to find the molar mass of the substance. Okay, and then we're going to use that molar mass to convert grams to moles. Sometimes we're going to need to convert milliliters to liters. Okay, and to do that, what we say is 1 liter is equal to 1,000 milliliters. Now, if we don't want to do a conversion, we can just move the decimal place 3 places to the left. And then you're going to plug everything into plug in and solve equation. Oh, no, sorry. You're going to plug in moles and liters into the equation. So let's take a look at what that looks like. Okay, so here's an example. I'm going to write down what I have. Okay, over here I'm going to write down what I need to know. I need to know capital M. I need to know moles. And I need to know liters. Okay, so here this problem starts with 12.5 grams, all right, of magnesium chloride, and then it's added to 4,862 milliliters of water, and it's asking us to find the molarity. Okay, so now if you look at this, to solve for molarity, we need moles and we have liters. We don't have either of those right now. Okay, so what we're going to do first is we're going to convert this 12.5 grams of MgCl2, magnesium chloride, to moles. Okay, we've done this so many times. We need the molar mass, so 12.5 grams of magnesium chloride, MgCl2, and I need to figure out the molar mass of that. So what I know is I know that magnesium, if I look at my periodic table, magnesium has a molar mass of 24.31, all right? And then chlorine, if you look at your periodic table, has a molar mass of 35.45. So we need 2 of those. Okay, so I'm going to add 20, let's see. To get the molar mass, I need to add this all together. All right, and the molar mass is 95.21. I'll write that up here. Okay, so now I just need to do a simple conversion. All right, so I'm going to put 95.21 grams on the bottom, and that is going to be equal to 1 mole of MgCl2. So I'm going to do 12.5 divided by 95.21, and that gives me 0.13 moles. Okay, now, so that gives me moles. Okay, so over here in my equation, I have moles. Now I need to find liters, and my problem gives me milliliters. So all I'm going to do excuse me, is I'm going to move the decimal. So I have 4,862 milliliters. I'm going to move the decimal 3 places to the left. So 1, 2, 3. So that gives me 4.862 liters. All right. So now that I have both moles and liters, I can plug them into my equation. So molarity is going to equal 0.13 moles over 4.862 liters. So now if I do my math, I get a molarity of 0.027, okay? And I can either use units just of a capital M, or if I want, I can write moles per liter, okay? So that's an example. Let's look at the next example, all right? It's because it's a little bit different, okay? This one is asking us how many moles of C3H2 would be in a 5-liter 2.6 molar solution. So let's look at what I've got. I have molarity, so I have big M, molarity is 2.6. And I have the volume, the volume is 5, excuse me guys, I'm losing my voice. The volume is 5 liters. So the only thing I'm missing here is moles. So I can plug this into my equation. Right now I don't have to use grams because I'm only looking for moles. So if I plug this in, I'm going to do 2.6 is equal to X. We need to figure out the number of moles over 5 liters. So I'm going to multiply both sides by 5. And that gives me X is equal to 5 times 2.6. Whoops. So that's going to be 13. So our answer for this one is just 13 moles. Okay, since the question asked us for moles and not for grams, we don't have to look at the molar mass. Okay, that's why it's important to look at each of these questions before you really get going too much, so that you make sure that you're solving for what you need to be solving for, okay, and not going to extra work. All right, so I'm going to walk you through all of these homework problems just so that you kind of, if you get stuck, you can figure it out. And I'm going to leave myself a little bit more room for writing here. Okay, there we go. Okay, so I'm going to write down what I've got here, or what I need in the end. So I need big M, I need moles, and I need liters. Okay, so let's see what I have. Okay, so it's asking me what is the molarity. So I'm going to be figuring out capital M. All right, and it tells me I have a 0.30 liter. So 0.30 liters. So that's where I need it. A solution containing 0.5 moles of NaCl. Okay, so this one's a nice one because it gives me liters, it gives me moles. So all I have to do is calculate. Moles is going to be equal to 0.5, or molarity, excuse me, 0.5 moles divided by 0.3 liters. So if I do that math, I get the molarity is equal to 1.67 moles. Okay, so that one was kind of easy because it gave us all of the things that we needed. So let's look at number 2. Number 2 says, if a 75 milliliter solution contains 0.0877 moles of copper carbonate, what is the molarity? Okay, so I need capital M, molarity, that's what I'm trying to find. I need the number of moles, and I need the number of liters. Okay, so it gives me the moles, 0.0877 moles, and it gives me milliliters. Okay, so remember, if I have milliliters, I have to move the decimal. So I'm going to move the decimal 1, 2, 3 places to the left. So my volume is 0.075 liters. All right, now we just plug this into our formula. 0.0877 divided by 0.075. And let's plug that into my calculator. And I should get 1.17 capital M molar, 1.17 molar. All right, is my final answer. So let's check out number 3. I have a feeling they're going to get a little bit tougher here before too long. Just a little bit. So number 3 says, what volume, okay, so let's write everything up here, moles, molarity, moles, liters. So it's asking what volume, so we're going to have to calculate liters, would, let's see, 0.25 molar solution, so that's big M, 0.25 molar solution can be made using 0.55 moles of calcium hydroxide. So it gives me my moles again, so 0.55 moles. Okay, so now let's set this up. Okay, we know that big M is equal to moles over liters. Okay, so that tells me I've got 0.25 moles is going to be equal to 0.5, this is molar, 0.25 molar equals 0.55 moles over liters. Okay, so now to solve this, I've got to do a little bit of algebra on it. All right, I'm going to multiply both sides times the volume. Okay, so this cancels out, and I end up with 0.25 times liters is equal to 0.55. Okay, now I want to get liters by itself, so I am going to divide both sides by 0.25. Okay, so that cancels out. So my volume, liters, is going to be 0.55. Oops, 0.55 divided by 0.25, which gives me a volume of 2.2 liters. Okay, so what you should be seeing as we go through these is there's not just a single way to carry out these calculations. Each problem can be a little bit different, and it's really important before you get started to know what you need to do. All right, so let's look at number 4. Okay. All right. So number 4 says, what is the molarity? So I'm going to make my list. I need big M, molarity, and then I need moles, and I need liters. All right, it's asking me what is the molarity of 650 milliliters of solution containing 63 grams of sodium chloride. Now, if you look at this, I don't have moles and I don't have liters. So this is one of those that's going to take a little bit of extra work. So to get liters, so I have 650 milliliters. To convert that to liters, I'm going to move my decimal 1, 2, 3 places. So my liters is going to be 0.65 liters. All right. And then I have grams. So this is where we have to think about the molar mass. So I've got 63 grams of sodium chloride. So if I want to convert to moles, grams of sodium chloride is going to go on the bottom. 1 mole of sodium chloride is going to go on the top. I've got to look at my periodic table because I'm looking for grams. If I do that, sodium is 22.99 and chlorine is 35.45. You get that from your periodic table. And then we're going to add that together. 22.99 plus 35.45. That gives me a molar mass of 58.44. All right, so I'm going to use that up here, 58.44. All right, and I'm going to solve for moles. So I'm going to do 63 divided by 58.44. And that is going to give me 1.08 moles. Okay, so now finally, I can plug this in over here, 1.08 moles, and I can finally solve for molarity. All right, big M molarity is equal to 1.08 moles divided by 0.65 liters. Okay, so let's plug that into my calculator. 1.08 divided by 0.65 is 1.66 molar. So my answer is 1.66 big M molar. All right, let's try number 5. All right. Oh, blurry. Let's try that again. There we go. Okay. So number 5 says, what volume, I'm going to make my list. I have big M molarity, I have moles, and I have liters. So it's asking me what volume, so how many liters is what it wants to know, of a 0.88 molar solution, so our big M is 0.88, can be made using 130 grams of iron 2 chloride. So we don't have moles and we don't have liters. We have grams though. So what we're going to do is we are going to convert 130 grams of FeCl2. We need to convert that to moles, which means we need to find the molar mass of FeCl2. All right, so check my periodic table. The molar mass of iron. All right, so I had to go check my handy cell phone app molar mass or periodic table. So the molar mass is 55.85. That's for 1 iron. And then chlorine is, we have 2 chlorines, so 35.45 times 2. I'm going to plug that into my calculator. I'm going to do 35.45 times 2 plus, plus 55.85. So my molar mass is 126.75. Okay, so that's what I'm going to plug in here, 126.75. So now I'm just going to take 130 divided by 126.75. and that gives me 1.03 moles of FeCl2. All right, now do we have moles? We have 1.03 moles. All right, we can plug this into our formula. So 0.88 molar is equal to 1.03 moles over X liters. All right, I'm going to multiply both sides times liters. Okay, and I get 0.88 molar is equal to 1.03 times times liters, so times X. And then I need to get X. Let me make this a little bit neater. I need to get X by itself, so I'm going to divide both sides by 1.03. And 1.03 is going to cancel out. X is going to equal 0.88 divided by 1.03. And that gives me a molarity, or not a molarity, a volume of 0.85 liters. All right, let's try number 6. All right, let's try number 6. 6 says, how many grams, I'm going to make my list, molarity, moles, liters. How many grams of calcium hydroxide are needed to produce 500 milliliters of a 1.66 molar solution? So we've got 1.66 molar. And it gives us a volume in milliliters. Okay, so what we can do then is we can move the decimal to get from milliliters to liters. We go 1, 2, 3. So this is going to be 0.5 liters. All right, and then we need to figure out the moles. Okay, that's what's missing. So we're going to do 1.66 molar is equal to the number of moles over 0.5 liters. So if I multiply both sides by 0.5, okay, liters will cancel out. If I do 0.5 times 1.66, I get 0.83 moles. Now, if you stop here, you're stopping before you need to, because look at the question. The question asked us to find grams. Okay, so in this case, we're going to have to convert our moles, so 0.83 moles. And what is our substance? Calcium hydroxide of CaOH2. We need to convert that to grams. So we're going to do the same thing. We're going to find the molar mass of calcium hydroxide, and then we're going to plug it in here so we can figure out how many grams. All right, so I'm going to look on my periodic table for calcium. Let's see, calcium's right there. Calcium is 40.08. And then we know oxygen is 16, but we've got 2 of them, so that's 32. And then hydrogen, we've got 2 of those, so that's going to be 2.02. So then let's add this up and see what we got. 40.08 plus 32 plus 2.02. 74.1. So we have a molar mass of 74.1 grams. So I'm going to plug that in here, 74.1 grams. And then I'm going to solve. So 0.83 times 74.1 equals 61.50 grams of calcium hydroxide. So our problem, we solved for moles up here, but then the problem wanted our answer in grams. So our answer is going to be 61.5. Go ahead and do number 7. All right. So number 7. Let me do my setup. I need molarity, moles, and liters. So how many moles, so it's asking us to figure out the moles of sodium chloride are present in 600 milliliters of a 1.55 molar NaCl solution. So my capital M is 1.55. Okay. It tells me I have 600 milliliters. So I'm going to have to move the decimal 1, 2, 3 places to the left. So I have 0.60 milliliters. And now I need to find moles. Okay, so if I plug this in, 1.55 is equal to X over 0.6. And multiply both sides by 0.6. And that'll get give me X by itself. So my answer is going to be 0.6 times 1.55. So let's see, 0.6 divided by 1.55, 0.39. So we're going to go with 0.39 moles. And we are done. All right. So I think that the most important thing that you get from going through these practice problems is that every problem can be very different from the one right before it or right after it. It's important to set it up and look at the units and decide what you have to do. Okay. The calculations aren't terrible. They're pretty straightforward, but you have to look, is your volume in liters? Does it give you grams or does it ask for grams? All of those things play into how you set up the problem. All right, so I hope that helped. I will see you in class. Have a wonderful day.